let's start. Thank you very much for the attendance on site and the visitors having in the stream. My name is Anton Dollmaier. I want to talk about automating monitoring. And in this talk, we are not talking about Kubernetes or this other fancy new stuff that will configure itself, but instead I want to focus mostly on, I wouldn't say regular systems, but systems that do not rely on containers. This brings a bit more different topic in this. In the end, you should focus on automating. Why? What's the issue? What's the issue that, at least I in this talk, want to present and talk to you about? Everyone knows the problem. Your boss, your colleague, friend of yours is approaching you, and they want to ask a favor. Everyone knows that. Just a small little request, small detail, nothing complicated. Could you please set up a new system? Could you please create this virtual machine? We need something for our marketing department. Not big, just do it. Needs to be done ASAP. We all know this. So you start. Everything is clear. Everything is perfect. You get going. Configure that system based on the request that you got from your boss. And finally say, okay, mission accomplished. System is live. We're good. Everything's fine. Everything's working. Until 3-4 weeks, sometimes months, perhaps worst case years later, customer calls, your colleague calls, something's broken. You have an incident, you have an outage. System that did work previously is now obviously not working anymore. And in that situation, well, you forgot. What exactly? Well, in most cases, you forgot not just to inform your IT department that there is a new virtual machine, but perhaps also you forgot backups. The system blew up because a fire destroyed your data center, like it happened in Strasbourg recently, or it just happened that you did not see it, so you forgot monitoring. Both cases should be automated, because we all know if something needs to be done manually, once a month, once a week, once per day even, it tends to be forgotten and then hazards break out. What do we do? Let's automate this. How you do this, obviously, is personal choice. This is up for debate. I want to talk about one option that solves the problems that I have now presented, but do not see this as an exact example, more like an inspiration for your own choice. In the end, what we do is configuration management. Configuration management not just helps us to make the task that we get presented and tasked with easier, but it also helps to automate certain very tasks that get very, very hard to do, or that you simply forget. My current personal choice of tooling for configuration management is the closed source or open source core tool Puppet. I have presented and started here a small manifest in Puppet. Nothing complicated. We just define a simple Nginx server for the fully qualified domain name. We want to have that in a static document root, have some index files presented, and of course, because we are not from 1990, we do IPv6. What happens with this manifest? We define, as in Puppet or in Ansible, if you want to do that, or Salt, or whatever tool you find suitable, we define the desired state. So as long as our our configuration management is working, this will be configured as we want to have it. Now we have the monitoring at hand. The configuration at hand. How do we monitor that? As I'm talking not about containers, I want to introduce the tool called Zabbix. It's not that complicated to set up, but it has certain advantages. For example, sorry, that was a bit fast. The architecture that you have with Zabbix is that, first of all, you have a central server, which gives us an advantage at hand. And you have the concept of so-called agents. And those agents are then called by the Zabbix server, if you have never heard about that, to monitor services like SSH, HTTP, and all the other systems. But you also have a proxy server which may be behind a firewall, so you can circumvent some kind of network teams that come in your way. On the web interface that Zabbix has, you have the ability to configure templates. Templates allow you to easily group certain tasks at hand. For example, for a mail server, which is based on Linux, we have a template for postfix, we have a general template for Linux, but we also have a template for Bacula, which allows obviously also to configure and supervise and monitor backups. That template is then thrown onto our multiple mail servers that we want to configure. Good. We now have the monitoring, we have config management. How do we connect those? First of all, Zabbix has a feature called agent auto-registration. How does this work? So you have set up your Zabbix server, as I've previously mentioned. You install now a Zabbix agent on your system that you want to supervise and you want to check. And this system has a specific configuration flag. It's called Zabbix server active, which is being used to connect back to the server. And when this happens, Zabbix receives an internal event. We can hook into this event, and when we do that, we can instruct the Zabbix server to automatically create that specific host if it has not been yet known. We can do that not only for example, creating the host if it's not yet known, but also add it to a specific host group based on the host name, for example, or apply certain templates to that specific host. So when we find a host which has a metadata attribute of web server, it automatically gets added to the group that will receive the notifications for our web servers, and of course it will be applied to the web server template. To make things fancy, I have prepared a demo, which will be now a bit fun to do because I have to watch on the beamer what's going to happen. So let's see. We have the web interface at hand. I have prepared that, and I need to find my mouse cursor. Here it is. Perfect. So how does this work? We have hosts, and I now have successfully managed to break the demo. One second. Again?
Can you zoom in?
I can, of course, if you give me a half a second to just remove that one and go back. Good. We have hello. Here we are. Are we here? Yes. We have the Zabbix web interface, and we have, of course, also our servers here. And that was the problem. I have prepared the Zabbix manifest for that one, the Puppet manifest, sorry for that. And what's going to happen is that this host will configure itself. It will, when I remove the comment, quickly check what should be configured. And when it does that, it will install the Zabbix agent, and it will start, obviously, the Zabbix agent. And when you go back to our web interface, as you can see, Zabbix agent is there. It's active. And when I go back to our web interface, magically, this host has already been registered in the background and is now live and able to be monitored automatically. So we now have the ability to simply, using Zabbix auto-registration, automatically at least register our hosts that we want to monitor in the live system. So at least you don't forget about the host anymore. But as I mentioned, this is not really that much of configuration management. We now have only included the basic setup, and with that, at least the agent gets configured on its own. As we want to automate that as well, Puppet does not have a state itself, so it is contained in the local agent that is being run. For that, we need a state aside of the actual Puppet node, and for that, the central Puppet server exports certain information into Puppet database. That database is not just used for the states and the resources that we want to manage, but also we can query it later for facts like what operating system are we running, are there certain host names active, what MAC addresses are we finding and using in that live system. And in the end, we also get information about the reports and, most importantly, the catalog of Puppet. As we're a bit techy here, let me quickly introduce how you configure it. Aside of, well, obviously you install the Puppet database packages, you have to extend the Puppet configuration, tell the server, okay, please send your reports that you will need and the hosts and the catalog configuration to Puppet database. We need a certain routes.yaml to also configure the PuppetDB here for the facts. And to make matters worse, we also need to send up SSL certificates to secure all this. Once we have this done, we can now use so-called exported resources. Exported resources in Puppet give you the ability to, well, as the name indicates, export a certain resource. How does this happen and affect the actual state? The difference between an exported resource and a non-exported resource is that the resource is not is declared on the agent, but it's not actually run on the local agent. Which means, in my case here, I define an SSH key based on the host name of a certain DSA type, and we use the fact of SSH DSA key here. And this SSH key gets exported into the Puppet database, where it can later on other hosts run a so-called fact collector or resource collector. And with that, I can simply merge and acquire every information that's part of that Puppet database matching the resource of SSH key. Obviously, this might work for SSH keys if you have not too large environment, but if you do want to have backups, for example, using Bacula or Barreos, you might want to limit the collection of those facts. For example, match only and collect only those facts that actually match this tag of Bacula storage director with a certain variable. This gives you, now back to the backups topics, the ability to automatically configure your hosts and let them back up on your Bacula director or the actual storage system automatically without further ado, without changing anything else. With those exported resources, let me go back to the demo. We now have obviously two hosts here. We have the Zabbix server and Kate as the second host. And if I refresh that, nothing changes, so it's still there. But when I go back to my other host called Robin, I can now let this node run again. And what will happen is obviously we will install the Zabbix agent again. And what we do not see, because it's stored only in the Puppet database, we will see that there will be an exported configuration. And I can now go back to my actual mouse cursor, here it is, to my actual Puppet server, and the Zabbix server obviously in that case. And I can run an agent here, and I can now collect all the information that I have previously exported in the Puppet database. Once that happens, our Puppet agent will use the API in the background of Zabbix that is being in use, and in that API call, simply issue a create command and start PostgreSQL. And as you can now see here, that host has been automatically created, Robin Andes. And to confirm, let's go back. Oh, it's already here. So this is successfully working. And with my configuration management, I am now able to use not just the native approach of Zabbix, but also the approach that Prometheus, that Puppet is giving me to configure hosts automatically. In that case, I have also used the Puppet module that's being curated by our open source community to automatically configure this node as a web server. Templates are here. So automatically added here as an HTTP service, and it's a Linux, and I can configure both of that in the repository, in the Puppet manifest of my agent that I do want to integrate. So the admin of your monitoring system has now one job less to care about. Good. Obviously, this was the part of the presentation that could have taken place also in 2018, 2021. Let's go a bit another approach. Obviously, there is a thing called Prometheus. Screen is not sharing anymore. There is a thing called Prometheus. I think everybody in the room should have heard about that. If you have not, I have brought the architecture diagram as well. And that diagram is a bit different to the one from Zabbix. Well, obviously, both systems are also from a different architecture. The main difference being that Prometheus obviously supports Kubernetes as well, which is out of the scope of this talk, but it supports the service discovery, which we will use. And Prometheus will also connect not to an agent as Zabbix is doing, but it will connect to the jobs and the exporters that will be configured as Prometheus targets. To configure that, I now also leverage Puppet, the same as before. The folks at Vox Populi have been kind enough to build a Puppet module around that. So we'll only use the includes for that. The include in that case being the node exporter, and because I don't want to configure another HTTP server, we will use Elasticsearch in that case. Additionally, you configure your system in Hiera as standard approach in Puppet, and I want to use the so-called export scrape job variable here to leverage our previously mentioned Puppet database. And I want to do that as well for our Elasticsearch exporter. And additionally, just for reference, the node exporter also will have a scrape job name called node. That's standard, nothing fancy here, nothing too explicitly configure even. On our server side, we are quite easy to integrate this. So we have the Prometheus server that's being included, and additionally we configure it and tell the Prometheus server Puppet module in this case. We will have scrape jobs here, and those two are called Node and Elasticsearch. What I now want to demonstrate, hopefully as successful as before, we will configure our system with Prometheus. I have another node here, which will be configuring the node exporter to make this quite easy. And that node exporter will be accustomed also with the Elasticsearch exporter. It's here, internet is working on that VM. System has been started, and I can now go back to our central monitoring server, and that monitoring server will do the same as it has done with Zabbix. It will collect and query the Puppet database, will check what's in there, what resources it has found. Hopefully in that case, this will be two jobs, one for the node and one for Elasticsearch. And this did work, as you see in the refresh. I can confirm this as well when going back to our Prometheus targets. I have that here. And as you can see, web interface has automatically reloaded. It was not yet scraped, but it has already been configured. We have a job here called Elasticsearch, and the other one for the node exporter, and those two will and are now actively scraped. So, challenge completed. We have successfully used our monitoring system to completely automate the deployment, the configuration of the systems at hand. You don't need to worry about forgetting them anymore. Obviously, the same concept applies to the backups. We are using the same with the RESTIC backups that we do. Barcolo and Barrios works the same. So you configure your system centrally. You use your configuration management to then have that information from your inventory and reuse it on your other infrastructure, for example, Prometheus or the Zabbix, the backup servers. And with that, you don't forget the system anymore. And when the next fire in Strasbourg will happen, or might happen, I hope it does not, at least you have backups and monitoring and get notified and get called. Good. We are back to the demo. This being said, please use configuration management. Please use automation, and that means I think it will help everyone in the room, not just in this room. And thank you for your attention. Let's see if questions are back.
Any questions? Any questions?
No questions.
I think I've overblown it. As I have mentioned before, yeah, one question.
Yes.
There you go.
Yeah, I have a question about Puppet exported resources. How do you do testing of your Puppet manifests with exported resources? I know that I have, I've never found a good way to do it.
You mean automated spec tests of that resources?
Just having a change in the Puppet manifests and checking what changed. I tried Octocatalog diff. I don't know if you know this tool.
I have known, yes.
And I never actually managed to do proper integration testing with the exported resources. So I was wondering if you had an idea about that.
I have a thought. This thought is first of all a bit embarrassing because we don't do the integration testing on the module codes themselves. We have a very large staging environment, and on that obviously also the exported resources work. So just a simple, well, more or less simple second setup with a Puppet server, Puppet database, and there everything can be tested and verified that is actually working without breaking production. Otherwise, just a note, the catalog diff should work on the Puppet server or where you actually collect the resources, because on the client where you run or we export the resources, nothing will happen. So there is also no change in the catalog. So I don't know if this helps or answers the question, but this should more than suffice in this regard to test on the node where you actually collect the information back. As I've also mentioned, just to clarify this as well, Puppet is my personal preference right now. If you have the same concept with Ansible, with Salt, please go forward. Nothing limited in this tool here. The general idea is that you use the information that you have in the inventory of configuration management to work with on the other sources. So feel free to adapt and improve.
Any other questions? Any other questions? No, yes, maybe?
If there are no questions, then I'm happy with that as well. Thank you very much for your
Thank
attention.
you.
And see you next time.